Hello everyone. Okay, so the set is Navdeep, a professor of statistical modeling of financial growth at a reputed management college, started a free one-day online session every day from Monday to Saturday. Navdeep found the following facts about the average age of the attendees, excluding himself, and the number of attendees, again excluding himself, who attended his sessions on the 6 days. Okay, so there will be 6 days, right? And okay, some attendees are attending the session. Okay, now every attendee was in his 20s, his or her 20s, and the average age of the number of attendees was an integer. Okay, when everybody has that age in 20s, the average is also going to be in 20s. And it is saying that it is an integer. Average age of the number of attendees was an integer on each day. Okay, so integer averages every day. Okay, because there are going to be some attendees every day. Okay, let's see more information about this. So yes, the number of attendees on all but 2 days were prime. Okay, let's see. Let's try to solve it. Okay, if I say that what are the days? It is Monday to Saturday, right? 6 days are there. So let me write here Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. So we have the number of attendees on all but 2 days were prime number. So there are two factors, number of attendees and their average age. Okay. So here it is also given. First thing is that all but 2 days. If I say here number of attendees, okay, number of attendees and their average age. Okay, there are two things. Okay, so he's saying number of attendees were all but 2 days means except 2 days. So that means 4 prime numbers should be there, right? So prime numbers, here number, in the number you must have 4 primes, right? Okay, so the number of attendees from Monday through Saturday were in increasing or AP. It is also increasing AP. One is there must be 4 prime numbers, and one is it is increasing AP. Okay. Then fifth point is that the average age of the attendees on Monday was twice the number of attendees on Friday. Okay, look at this. This is an important point. Because when you say Friday, right? Monday it is double the number of attendees on Friday. But you know, average age cannot be any other but in 20s, right? And it is double of something, right? Double of an integer. That means it is going to be even number, right? Even number in 20s. So Monday, even number in 20s, the age can be, average age can be 22, 24, 26, 28, right? You can take 20 also, right? In 20s, if somebody says you can take 20 also, but okay, let's say. And now, but if you take average age on Monday is this, right? That means on Friday, the number of attendees must be 10, 11, 12, 13 or 14. Why? Because the average age is double of the number of attendees on Friday, right? Okay, now I need to check something, right? Because I want that there must be 4 prime numbers and number of attendees must be an AP, right? So if I take Friday to be 10, okay, I'm just taking here the value, right? Let's say Friday to be 10. Okay, if number of attendee on Friday is 10, so what AP you can have, right? You can have AP as 9, 8, 7, 6, okay, AP with the common difference of 1. But here, can you think there 4 prime numbers are there? Only 7 and 11 are prime. So no, this is not possible, right? So I am removing because I have less space here. You can write these. So I am just taking Friday as 10 first. Now the difference can be 2. So 10, 8, 6, 4, 2. But these cannot be prime numbers, right? There must be 4 prime numbers. So this is also gone. So that means 10 is not possible, right? 10 is not possible. Why? Because you cannot have that AP, increasing AP you cannot have. So 10 is gone. So next is 11, right? If I take 11 here, right, on Friday. So what are the possibilities? If I take 10, 9, 8. So here 3 terms which are not prime, right? Only not prime should be 2. Composite number should be 2, right? Rather not prime, because 4 must be prime. So this is not possible. Again, this is not possible, right? So if I take 11 with a common difference 2, right? So then it can be 11, 9, 7, 5, 3 and 13. So here 3 is prime, 5 is prime, 7 prime, 11 prime, 13 prime. There are 5 prime numbers, only 4 should be prime. Okay, so this is also gone. So that means 11 is also not possible. Okay, 11 is also not possible in case of Friday. So let's say I will take the next one, right? Now 12, is it possible? Just see that whenever you take 12, right, 12 is not prime, 12 is not prime, and if you take one difference, this will be even, this will be even, so this will be not prime, so you cannot take difference of 1. If you take difference of 2, all will be even, so that is also gone. So 12 is not possible, right? And 3 difference here is not possible for 12 because the first term will become 0, right? And now let's take 13. If Friday is 13, I'm writing here, okay, 13. So if I write 12, 14, 12, so one difference I cannot take because then 14, 12 and 10, so there will be 3 even numbers which are not prime. But if I take the difference of 2, right, then it will be 11, 9, 7, 5 and 15. Here you can see except for 9 and 15 all are prime, 5, 7, 11, 13 are prime, so there are 4 prime, so possible. So one case is this case is possible, right? So if I take the difference of 3, right, let's take difference of 3 also in this case, 13, because this is also possible, there are 4 difference, 12 possible, right? So first term will be 1. So here it will become 13, 10, 7, 4, 1. But 1 is not prime, 10 is not prime, 4 is not prime. So that means I cannot have 4 prime. So this is also not possible, right? So 13 we have one case, right? Now I am taking 14, right? There is one more possibility, 14. So 14 you cannot have difference of 1 because 14, 12 and 10 there will be 3 non-prime numbers. If you take difference of 2, all even numbers would be not prime. If you take difference of 3, so 14, 11, 8, 5, 2 and here it would be 17. Now 2, 5, 11 and 17 there will be 4 prime. So second case. So this was case number 1, right? This is case number 2, right? Where numbers will be, right? Attendees will be this. Accordingly I will see the average age, right? So there are 2 cases possible. Because average age I got 1 at least because the average age on the Monday is twice that of attendees on Friday. Friday is 13, so Monday average age will be 26 here. Here it is 14, so it will be 28 here. So average age here will be 28, okay, on Monday. Okay, after that we will see what else is given. Now it is given, right? Anything else is given? Let's check it. So first it was that every attendee was in his 20. The average age of the numbers of attendee was an integer on each day, right? So we got it that Monday we got average age as 26 or 28 in respective cases. right? Then it is about number of attendee, right? And the average age on Monday we got, and every attendee joined in the beginning of the session. This we got. Now the last paragraph, what is it saying? After the completion of the courses, he found that change in the average age of the attendee at the end of the session on the day with respect to the beginning of the previous day, and plotted the following graph. Okay, there is a graph also. We have solved without seeing the graph. Right, on Monday he kept the change the average in the average to be 0, as he assumed that the previous day the average age of the attendee had been the same as those who joined on Monday. Okay, that means Monday this is the average age. We got 26 and 28 in the two cases, and the change in the average is given in the graph. Okay, this is the change in the average age, right? Okay, so here Monday there is no change. Tuesday it is +1, right? Tuesday it is +1. So can I write these, okay, average age here, because Monday in one case it was 26, other case it was 28. So when the change will be Tuesday, it will become 27 +1, it will become 29, the second case, right? And Wednesday it is no change, so it will become 27 and 29 only. Thursday it will be -2, so it will become 25 or 27. The average age, this is the change in the average age, right? So it will become +1 on the next day, 26 or 28 again, right? And Saturday it will become -1, so it will be 25 or 27. So this is the average age per day, right? And the number of students also, you can write number of attendee. Okay, number of attendee we already calculated. That was in first case it is 579, right? That is AP with 2 difference, and second is 258, so AP with 3 difference. Okay, so in the first case number of attendee are so 5, 7, 9, 11, 13, 15. In the second case it is 2, 5, 8, 11, 14, 17. Okay, these are the number of attendee. Okay, number of attendee. Okay, here also it is number of attendee, and this is the average age. So here also it is average age. So there are two cases. I have written first case here, right? Second case here. So these are the two cases, and I got the number of attendee and the average age every day. Okay, so I know that. Okay, now we can handle, I think, the questions, and the questions are, okay, there are 4 questions on this set. Okay, let's do it one by one. Okay, this we have already solved, right? We have already solved this. So let's come to the questions. Okay, you can write down those 2 cases here, but let's come to the question. Here, what is the number of attendees on Thursday? Okay, we have already done this. So number of attendees on Thursday is, it is 11 in both the cases. So 11 here, 11 here. So I can mark this. Otherwise I would have marked cannot be determined if there are 2 possibilities. But here in both the cases you have 11, right? So you can mark the answer for first question as 11, right? Okay. And yes, 11 is the correct answer, right? The highlighted one. Okay. Second one is, okay, second is the maximum difference between the total age of participants on Monday and that on Saturday, right? So I want maximum difference on Monday and Saturday, right? Maximum difference. Let's see. Okay, what can be the maximum difference between the total age? Okay, let's come back to that. Okay, so here maximum difference we are talking about in the total age. Okay, so total age on Saturday, right? Here it is number into this, so 15 into 25, this will be 25, 16, 400, 375, right? The total age. And here the total age will be 17 into 7, 119, 34 and 11, 445, right? So the difference here you can see 4, okay. Okay, wait a minute. Okay, I'm taking the difference here. The difference between Monday and Saturday. Sorry, Monday and Saturday. So Monday it is 130 and 375. So in this case, the difference is 245, and here 28 into 2, 56. So 56 and 459, the difference is 403. Right? So maximum difference is talking about it should be 403. Right? Okay? Because in one case you are getting Monday and Saturday, the maximum difference in the total age. Right? Total age is number of attendee into average age. That is the total age. Right? So the difference in case of first case it is 245, but in the second case it is 403. So we will take the maximum difference, and that is going to be 403. Right? So we can mark D option, which is 403. Okay? Yes, it is the correct answer. Okay, so let's move to the next one. What could be the minimum age of the youngest attendee on Monday if the number of attendees on Monday is the least possible? Right? Okay, Monday in the second case, the least possible attendee were 2 only. Right? In the second case, we have 2 attendee only, and the average age is 56 in that case. Right? This is the second case. Okay, case number 2, where we have number of attendee. Okay, attendees are 2 and the average age is 56. Okay, so average age is 56 or the total age is 56. So total we calculated, average is 28. Sorry, average is 28. Okay, in the second case, average age is 28 because average is in the lines of 20s only. Right, so the total age was 56 in the case of second case. Now the thing is, he's saying what could be the minimum age. Now minimum age, when I say, right, you could have thought that the total is 56. So A plus B, there are 2 persons whose total age is 56. So you will minimize A to get the maximize this, right? He is talking about minimum age. So one you maximize, one you minimize, right? Which you can think that it could be 0 also, it could be 1 also. But the problem is that they are all in their 20s. Right? So they cannot be. So the maximum age cannot be more than 29. So the minimum age will be 27 only because the total is 56. So 27 should be the answer because their average is 28 and there are only 2 attendees in the case of second one, right? Where we are talking about the number of attendees on Monday are least possible. Least possible, I will take the second case where there are only 2 attendees, right? And in that case, if average age is 28, okay, so one must be 29, one must be 27 to get the minimum age. Okay. So yes, 27 is the correct answer. And now question is on how many days is it possible that the age of every attendee is a distinct integer? Okay, let's see. Okay, let's bring this data, right? I'm bringing this data on the, so whatever data we have calculated, I'm bringing on that screen only. Okay, just give me a second. So here we have, the question is, what could be the minimum? No, what could be the, sorry, on how many days is it possible? Okay, so I'm bringing whatever we have already solved right on that screen. Okay. So let's see the question again. So this is the question. I've brought the data that we have already solved in the screen. Right, on how many days is it possible that the age of every attendee is a distinct age in a year, right? Okay, see, a distinct age because they are all in 20s. right, can be a maximum of 9 or 10 distinct, 20 to 29, maximum 10 distinct numbers, 10 distinct integers. So whenever the number of attendees are more than 10, so here it is more than 10, right? On Thursday, Friday, Saturday, you take any case, it is number of attendees are more than 10, they cannot have distinct age in integers, right? Why? Because they are all in 20, so 20 to 29, distinct can be only 10, right? Okay, this is one thing. And now if I talk about Wednesday, right? Wednesday, right? The minimum average is 27. If average is 27, if I say that there are 9 persons who have different age, right? So if I take 127, then 28 and 29, there can be only 2 persons having more age than 27, right? Plus 1 plus 2. So there can be 26 and 25, only 2 persons balancing these with a distinct number to have an average of 27 only, right? So I can have only these 5 people having distinct numbers and having an average of 27. Because if I take 24, right, I need 30 also, right, to have that same average. Okay, so I cannot have 9 persons. 9 persons average cannot be 27 if they have distinct age, right, and they are all in 20s. Okay, so that is the problem. With 29, this is a huge problem, that 29, right, 8 persons, because 29, more than 29, nobody can have that age more than 29. So everybody must have 29 only to get this average. Okay, so this is also not possible, right, because he is saying not possible to have distinct age. So Wednesday also it is not possible, you take any case. Same thing happens with Tuesday also, because Tuesday 27 age is saying 7. We saw that in 27 we can have only 5 distinct ages, right, if they are all in 20s. And 29 we cannot have, right, any person more than 1 having 29 age. Okay, so that means this is also not possible, right? So only possibility is for Monday. For 26 it is possible, right? 26 you can have, let's say 27, 29, let's say. Okay, 2 persons having this 27 and 29, this will be plus 1 and plus 3. Okay, or let's say 26, 27, 28 and 29, right? 3 persons here, because I want total of 5 persons. So already 4 persons are there. This is plus 1, plus 2, plus 3. So plus 6. So I can have 20, right, balancing this. Or I can have only just like this, that there are 5 persons, 26. So 27, 28, 25, 24. Okay, so balancing the average at 26, and the average would be 26, and there are number of persons having distinct ages will be 5. So there will be multiple combinations, right? For 28 we have already seen 27 and 29. So that means only on Monday it is possible to have attendees with a distinct ages, right? Whether you take case 1 or case 2, only Monday. So that means the rest all 5 it is not possible. On 5 days it is not possible. Okay. So yes, C option 5 is the correct answer.